Because of the brief nature of this unit, we're not going to do SAT practice on these notes. We're just going to try to get right through them. Make sure again that you do these daily, work for the videos before you go backwards, because every day has something new. Today we're going to look at solving systems of equations. What we call a system of equations is two or more lines of equations containing two or more variables. It is mathematically impossible to solve for two variables with one equation, and the number of equations must match the number of variables. So if you are giving something where they're asking you to solve for x and y, then you have to have two equations, one for x, one for y. Now they can both be in each one, but you have to have two. If they're asking you to solve for a, b, and c, because there are three variables, you have to have three equations. And again, that's just a general idea. Today's topic is going to be solving by graphing. In this lesson, you're going to have to recall your skill of graphing lines, which I hope you have done. Let's look at a real quick review of two basic graphs that you had to do last unit. This right here says graph y equals 2x minus 3. Again, this is slope-intercept form because it starts with y equals. Keep in mind that this minus 3 means, of course, we're counting by ones. Go down 3, 1, 2, 3. And that the 2 is the value of m, which represents slope. 2 turning into 2 over 1 means go up 2 over 1 and draw a line through those 2 points. Again, I don't have my ruler, but general idea. Again, make sure that you draw those graphs all the way across the grid. But other than that, as I said, that is the first type of graph that we saw last week, or last unit. The second type was in standard form because x and y are on the left with the constant on the right. In that one we had to do our x-intercept. And in order to get our x-intercept, we learned that we needed to ignore y, and so we would write 3x equals 6, which means that x equals 2, again counting by ones here. X would be 2 right here. Y-intercept was found by ignoring x, so we found 2y equals 6, which means that y, of course, equals 3, not 6. And you go up 1, 2, 3, and again draw a line through both of those things there. Hope I do it right, but you get the idea. Again, with that, and if you're going to solve by graphing, you have to kind of know how to graph, especially on this test, because the test is not on computers, and so you'll have to be able to graph. What I'm noticing is that people know how to graph on computers, but they're not graphing so well on paper, and you have to kind of translate that skill over. When solving by graphing, we must learn to understand what a solution looks like. For this, we will use our calculators real fast to solve the following system. You might want to get your calculators out and do this with me. I taught you earlier how to graph by hitting the y equals button, and it brings up that menu. And I also taught you that anytime you have a fraction, you probably want to use parentheses. So I'll do negative parentheses 1 divided by 3 x plus 3 for the first graph. And then I'll just arrow down to the next line, and that's when because it says y equals, again y equals, I'll just do x minus 1, and then we'll hit the graph button. And that will make two graphs. It always graphs the first graph first, the second graph second. And so this is the negative 1/3 x plus 3. This is the x minus 1. And you notice that both of these graphs cross and they touch. And so what we would do if you're going to use the graphing calculator to solve a system by graphing is that, remember before when we did linear regression, we calculated a linear regression. This time we are going to calculate. If you look right above the trace button, you see calc in blue, so you hit second, calc, and we want to calculate the intersection of those two lines, which is just by hitting the number 5 or scrolling down to 5. But anytime they give you a menu and there are numbers or letters, you can just hit that number there. It then says first curve, so it's asking you where do you think the first curve is going. And again, you notice as I arrow left and right that little x is moving on my first line. It doesn't really matter for this where it's at yet. You're not into complex enough stuff to worry about it, but I'm just going to put it pretty close to where it is. Then you hit enter, and then it says what is your second curve? Where do you think it's at on your second curve? And that's again where you you notice that the x is moving along the second line. Put it about where you think it's at, and it gives you a guess. That's not what we want. You hit enter one more time, and it tells me that the intersection is at 3, 2. What that means in terms of, I'm sorry, I wrote it in pencil. It tells us that the intersection is 3, 2, and what that means is that 3, 2 works for both graphs. So if I do negative 1/3 times 3 plus 3, I get 2, which means that it works for the first one. If I do 3 minus 1, I also get 2. So pretty much plugging in x to both of these equations gives me the same value of y for both of those equations. So a solution is the point where the two lines touch. It is the point where both equations have, or still one point that both equations have in common. Sometimes, and you'll learn later, that there are equations that have 2 or 3 or 4 intersections, but for right now you're only going to see one. But again, the actual definition is that it represents the point or points where the equations intersect. Consider the following systems that have already been graphed for us. So if you see this question on here and it says, what is the solution of the equation? First thing you do is remember that the solution is the point that both lines have in common, which is right here. And all you have to do is write down the coordinate, which is 3, -3. And that's it. There is no work on that. Here again, if you were asked to find a solution of this, you find a point where they both cross and you give the proper ordered pair of 3, 1. If you've had issues with plotting points, then it's going to be an issue because you obviously have to give the proper order of numbers in order for that to be right. On today's work, you're going to be asked to graph each equation on the computer. So you have to actually do a graph of each equation, and then you'll have to use that graph to identify the solution. It is not major, but again, your graphing skill has to be up to speed. Today's notes are short because it's not always the best strategy to solve by graphing. Imagine the imperfections that we have in that our lines aren't always exactly where they should be, that they won't always exactly be straight. And if you're looking for a point of intersection, you start getting into weird locations. I won't even put you through that. I do suggest that you do your best to get high grades on today's assignment so you do not have to return to it. Again, I think that the major issue some of you have is that when I'm doing 6.2, you're still doing 6.1, and it messes everything up. Either way, the deadline for these is Friday, and many of you still have assignments to make up, so it does help if you get through fast today so you can actually work backwards. And I will remind you again, this is a 2-week lesson, so it requires the highest degree of respect in terms of your effort. Please don't mess around with this because this test could hurt you big time. My advice is again that you begin by mastering your graphing skill because the last 2 lessons are based on it. And if next week you're not 100% confident, then you will not be able to perform properly. Other than that, do the following bell ringer for me. That is, if you want me to assist you on anything you're working on, because if I have not marked you down for a bell ringer, I am not going to answer any of your questions, and that is our new agreement. Other than that, good luck.